All right. Hey, you guys. So I got some email questions about specifically the x and y intercepts of 5.4 and 5.5. And then there was one additional question. This one was number 16 from the 5.5 lesson here. So I'll put 16 there. So let's start with 5.4. Remember, our x-intercept is always x comma 0. And then our y-intercept is 0 comma y. So the value that we're looking for is still going to be there. It's the other one that gets turned into 0. So some of these are really simple. The y-intercept is going to be a straight calculation where the x-intercept will require opposites. So if I'm replacing the y with 0 for this one, I can zoom into this problem here. That's going to give me 0 equals 3 to the x plus 3 minus 8. We isolate the base, so we're going to add the 8 to both sides, giving us 8 is equal to 3 to the x plus 3 power. Now we need to BAP it. So it's base, oh, I put it backwards. I'm saying BAP. I know it's base power equals answer, and now we need to put it into log form. Log base answer equals power. So that's going to say log, the base is 3, the answer is 8, and it's equal to the power of x plus 3. So, yep, this one has the word log in it because 3 to nothing that we know, that's like a whole number, is going to give us 8. And so then my last step is to subtract the 3. So my exact answer as the x-intercept is going to say log, I'm going to do the base change formula, log 8 divided by log 3, and then minus 3 comma 0. In your calculator, you can do this, and I'm going to use the calculator on my phone. In that case, I turn it sideways. I'm going to start with the number 8, then I hit log. Then I do the number divided by the number 3, then log. That gave me my answer for log 3. I hit equals to finish the division, and then I'm going to subtract 3. I got negative 1.1072. And I think that that's good. Nice. So then for the y-intercept, let's switch over to purple. And we'll go to blue for the y-intercept. So all of that was just the x-intercept. In that case, our y-intercept, we're going to start with the same problem. You're going to love the y-intercept. We keep y. It's 3, 0 plus 3 minus 8. So you can see that I'm just going to simplify this to get 3 to the third power minus 8. I just started thinking of the answer and writing that down. I can see why we could make mistakes. So 3 to the third power, that's 27 minus 8. I'm getting 19. And I've got the answer 0 comma 19. Beautiful. So let's do the same thing on number, well, these next two. Oops, I forgot to change this one. It was supposed to be +1. I think I'm -1. Okay. So then I look at this next one. I see that it's going to be the same work, but I will do it with the base 2 instead. So check this one out. When I replace the y with 0 to find the x-intercept, you can see that the first step is to subtract the 5. And then this creates a conundrum. -5 is equal to 2 to the x plus 4 power. Nope. Negatives are never equal to a positive base. So this problem is unsolvable. There's no solution. For who? For the x-intercept, That just means that this function does not end up crossing the x-axis, which means it's floating above the x-axis. So cool. Now to find the y-intercept, we just do the work of plugging in 0 for x. So we've got y is equal to 2 to the 0 plus 4 plus 5. It will still have a y-intercept. That's giving me 16 plus 5. I'm getting 21. Easy. So the y-intercept is a lot easier in this case. Finally, here's another one. This one is fun with the base 2. So when I've got 0 is equal to 2 to the x plus 4 minus 1, whenever we have a minus here, provided that there's no minus there, we'll get a solution because it's shifted down below the x-axis, which you'll see next unit. That's going to give me 1 is equal to 2 to the x plus 4. And here, instead of using logs, I'm going to use the common base. So 2 to what power gives 1? 2 to the 0 power is equal to 2 to the x plus 4. And now you can say, oh, the bases are the same. We'll cancel those out. And we'll get 0 is equal to x plus 4. X is equal to negative 4. And that was just kind of fun. Negative 4, 0. So I wanted to show that sometimes there are cases where you could use that common base like we did in 5.3. And then the y-intercept for this one, again, we're going to have 4. So that's going to be 16 minus 1. We're going to get 0, 15. So that was just a refresher on the x and y intercepts from 5.4. In 5.5, we're going to see the exact opposite kind of work because we have logs. And on the inside of a log, it has to be positive. So let's look at number, well, whichever one's here. So to find the x-intercept, it's x, 0. So the y value is replaced with 0. And I'm just writing it down again. Now I'm going to isolate the part that has logs. To be sure, that's just this part that has log. So I need to get rid of the 6 and the negative 2. So I subtract the 6. Then I'm going to divide by negative 2. Negative divided by negative is positive. So I'm getting 3 is equal to log base 3 of x minus 5. Even if this had been a negative 3, which it is not, remember that's the power. This is the log back form. Log base answer equals power. So at this point, what we're doing is a conversion. We're going to convert back into exponential form. So the base is 3. The power is 3. It equals x minus 5. And so from here, you're like, oh, 3 to the 3rd power, that's easy-ish. Let me create more space for myself. 3 to the 3rd power is 20. Oops, I wrote 30. I meant to say 27. And that equals x minus 5. Don't get this wrong in the last step. We're going to add the 5, and we're getting x equals 33. And let's see, 33 minus 5. Nope. 32. 32, 31, 30, 29, 28, 27, 32. 32 minus 5 is 27, and so that works out nicely. 32, 0. Funny. All right, and then when we go to find the y-intercept, so this time we'll see when I'm talking about where is the exclusion with logs. So the y-intercept is 0, y. That's going to be y equals, we'll do it right here, negative 2 log base 3 of 0 minus 5 plus 6. So right here is where we're seeing the issue. That gives me negative 2 log base 3 of -5 plus 6. This is a domain error. This number in here has to be positive. So because it's a negative, this means that there's no y-intercept. So this function doesn't cross the y-axis, but it always crosses the x-axis. So when we look at the graphs of logs compared to exponential, you'll see that one has a domain restriction and one has a range restriction. And so when there's a range restriction, it's possible that there's no x-intercept. When there's a domain restriction, it's possible that there's no y-intercept. Pretty cool. Now, on the other side of that, we have problems like this one here, which will have solutions, and let's practice this one. So again, to find the x-intercept, we replace y with 0. I'm just doing that. And what we're going to do is we're going to isolate the log. So which part is the log? There's no factor in front of the log this time. So this is the log part. So I need to get rid of that -1. Adding 1. I'm going to get 1 is equal to log base 1/2 of x plus 4. Now it's in the BAP form. I need to unbap it. The base is 1/2. So I'm going to go 1/2. The power is 1. Nice. It equals the answer of x plus 4. So then we can see we're going to subtract 4 minus 4. 4 minus 1/2 is 3.5. So I'm getting x is equal to -3.5, comma 0. That's a good one. Finally, to find the y-intercept. Okay, we might need to use a conversion for this also. Let's take a look. So in the y-intercept this time, we're going to plug in 0 for x. So I'm going to have y equals log base 1/2 of 0 plus 4, which is just 4 minus 1. So it's this expression that I need to evaluate. As a reminder, it's saying 1/2 to what power is equal to 4. So if you don't know, yes, you may use your calculator for this, but we do want to be able to say, oh, we could rewrite both of these with a 2. The 1/2 would be 2 to the -1 power, and that's equal to 2 to the 2. And then you could see, oh, with the same base, it's going to give me -1x is equal to 2, dividing by -1, you're getting x is equal to -2. And let me see, a negative exponent here is going to flip it upside down, and 2 squared is 4. So that means that this part evaluates to -2. When I subtract 1 more, I add and keep the sign the same to get the y-intercept of 0, -3. And that's that. Super fun. If you can't do the math, right, sometimes you won't be able to, then you'll just put this exact answer in right here. But if it's a 2 and a 4, look to convert it. If it's a 3 and a 9, look to convert it, because those are ones that will simplify. Of course, your calculator would tell you that, and you want to remember the log base answer. The base change formula is log answer for above and log base. Oops, I forgot the log word. Base for below. All right, our last question that was related to these and is similar was the one number 16 on 5.5. So where did it go? This is a great problem. We're getting to see the properties of logs. I noticed that log is written in this everywhere. Log, log, log. So we're just going to start using the properties of log. Instead of plus, we're going to write that as a single log. And it's going to be 4x times x plus 4. And then it equals log base 3 of 9. So now it says, even though it's big thing, this and that, it says log. That means that the logs cancel. They have the same base. To simplify, I'm going to distribute in this next step to give me 4x squared plus 16x equals 9. I see that there's an exponent of 2 here. This is a quadratic. I'll need to solve by factoring or the quadratic formula. To do that, I need to make one side equal to 0, so that's why I subtracted the 9, and that gives me 4x squared plus 16x minus 9 equals 0. I don't see any common value. 4 times 9 is 36. It would be a negative, and we have a positive 16 here, meaning I want positive 18 minus 2. 18 minus 2 is 16, and 18 times 2 is 36. So this is going to use that factor by grouping. 4x squared plus 18x minus 2x minus 9. Uno, dos, tres, cuatro. Taking out from the first half the 2x, we leave 2x plus 9. Taking out from the back a negative 1, 2x plus 9. The binomials match, 2x minus 1, x, oops, I forgot the 2. 2x plus 9 is equal to 0. Now we have 1/2. We have negative 9/2. I don't think that negative 9/2 is going to work. Let's check. We can never have a negative in the log. This had logs in it. So coming back to the original, yeah, the negative 9/2 is not going to work. And so let's try it with the 1/2. Half of 4 would be 2. It would be 2 times, and then it's half plus 4, so 4.5 equals 9. Yes, mathematically it works. And it creates all positives in the log. So the answer is x is equal to 1/2 or 0.5 this time. So that's all for those questions related to logs. I'll do another one related to the warm-ups.